Welcome to episode 25 of CipherVibe's end-to-end cloud security architecture course. Cloud security frameworks turn risk into prioritized safeguards and assessments. They guide design and assurance, not replace accountable judgment. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Frameworks organize the control layers covered throughout this course: identity, networks, workloads, data, software delivery, logging, detection, response, governance, and shared responsibility. They help teams communicate consistently across technical and executive audiences. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is use CIS for configuration hygiene. CS benchmarks provide consensus-based configuration recommendations for many cloud and technology platforms. Use them to establish a baseline, tailor settings to your architecture and risk, manage exceptions, and verify remediation rather than blindly applying every recommendation to every workload. The second building block is use NIST for control architecture. NIST SP 800-53 provides a broad catalog of security and privacy control outcomes that teams can tailor to systems and risk. Use it to reason across access control, audit, configuration, incident response, supply chain, and other families while preserving the link between requirements, implementation, and assessment. The third building block is use well-architected guidance for cloud decisions. AWS and Azure well-architected security guidance, along with similar provider resources, help teams evaluate cloud design choices in the services they actually use. Apply the principles during architecture review and lifecycle change, not only as a once-a-year questionnaire. The fourth building block is create one integrated control model. Define your organization's control statements, map them to relevant frameworks and provider guidance, and collect evidence once where it supports multiple obligations. Keep framework mappings current, but prioritize the actual security outcome and the operational owner over a collection of disconnected compliance dashboards. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A practical framework pattern defines common internal controls, maps them to configuration benchmarks and external requirements, embeds provider guidance in architecture reviews, and uses evidence to measure whether the controls are operating. Implement this layer in a sequence that preserves evidence and limits blast radius. First, select frameworks that match scope, obligations, and cloud providers second. Define common internal control statements and owners third. Adopt a tailored CIS baseline for priority services fourth. Map evidence to NIST and well-architected review questions fifth. Review exceptions, measured gaps, and changes on a regular cadence. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, attempting to implement every framework control without risk-based tailoring second, using a benchmark tool result as the only architecture review third, maintaining separate evidence sets for every framework fourth, failing to revisit mappings after cloud service or organization changes. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, sample benchmark findings and confirm business context remediation second. Test one architecture review against the integrated control model third. Measure control coverage, exception age, and evidence freshness fourth. Review crosswalk accuracy when a framework or provider guideline updates. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, create a lightweight framework crosswalk for a fictional cloud storage service, including owner, evidence, and one tailored exception. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that cloud security frameworks becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.